Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Logarithmic Formula Memorization Basics. Concept number 9, Logarithm Change of Base Formula. Log base b of x is equivalent to the log base c of x divided by the log base c of b. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is super effective. I'm coaching you to turn your wants and desires of getting an A or perfect test scores into a brand new paradigm. I want to include everyone who needs a boost in Algebra 2, and if I could stick every single math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com to order your healthy dose by purchasing the complete Algebra 2 Cram session beyond the logarithmic formula memorization basics. You have lots of peers, classmates, and or colleagues who could really benefit from this Cram session as well because they're taking Algebra 2 with you. So tell them to inbox me at memedicine@gmail.com so that they too can order and purchase the complete Cram session. You'll be glad you spread the word because they'll make great study buddies. Let's delve into the concept. Logarithmic formula, change of base. Use the log base b of x to demonstrate the change of base formula. Definitely press pause if you need to, and I'll give you a moment to think. All right, so hopefully by now you are able to press pause and come up with a formula. And if you don't know what the formula is, that's completely fine. Let's tackle this together. Before demonstrating how to arrive at the formula for the change of base, we first need to understand the general format for an exponential function, because exponential functions are the basis for all logarithmic functions and formulas. The general format for an exponential function is y equals b to the x, where b is going to be positive and not equivalent to 1, okay? So it's not going to be negative or equivalent to 1. And here goes a general depiction of what an exponential function would look like on a coordinate plane, okay? And don't confuse this format with a polynomial format where our base or constant is going to actually be the independent or input variable x, and the exponent in a polynomial formula would actually be a constant, like 2, 3, 4, okay? But here the constant is the base in an exponential format, and the exponent is the independent input variable. And in an exponential function, the output number or function that you get by multiplying the base by itself however many times the exponent dictates is called the power. Okay, sometimes the names power and exponent are interchanged, and technically that's a misnomer. What you could say if you were to assign the exponent an input value of 2 is that the output result y would be the second power of the base b. Okay, that's how you would express that correctly. All right. A logarithmic function now is going to be the inverse of the corresponding exponential function with the same base. Okay, this means that our logarithmic expression y is equivalent to the log base b of x is equivalent to basically x equals base b raised to the y, okay? And whenever you see a logarithm, it's easier to think about the equivalent exponential form in your head, this form right here, okay? And remember that algebraically, in order to yield the inverse function of your starting function, you have to switch the independent or input and dependent variables, or simply put, switch the x and y values. So for this or any inverse function, constants remain constants. So the exponential constant is going to be a constant in the inverse logarithmic equivalent, expressed in exponential form. I know that's a mouthful. And the power is now going to be our former independent variable x, and the exponent is going to be y. Okay? Alrighty then. Hopefully you're not worn out, and let's continue. On a coordinate plane, the logarithmic function is going to be the reflection of the graph of the corresponding exponential function over the line y equals x. Okay, so here goes what our logarithmic function looks like. All right, we basically flipped it or reflected it over the line y equals x. So in the case of log base b of x, you have that it's going to be equivalent to this formula, the log base c of x divided by the log base c of b, okay? And just take it in for a moment. Alrighty then. The idea is that if we take the logarithm of base b of x, we can turn this into an equivalent ratio of logarithms, choosing any base that we want. And here the placeholder for any base that we want is just assigned a value of c, the alpha value or the variable c. And the power you are evaluating in the original logarithm, okay, is now going to be the power of the numerator for our new base, and the original base that you were evaluating previously is now going to be the power being evaluated in the denominator. Okay, so that's basically our change of base formula. It's a ratio, and I know what you're thinking. Okay, so how do we go from this to this, or prove that the left-hand side is equivalent to the right-hand side? All right, so let's sort this out by doing some relabeling. We can re-express the left-hand side by assigning it a variable value. So we can say that m is equivalent to the log base b of x, okay? And if we convert this logarithmic expression into exponential notation, as demonstrated previously here, we can also re-express this as x is equivalent to b raised to the m, okay? Based on what we just were introduced to with the equivalent exponential expression for a logarithm, okay? Now what we're going to do next is introduce the logarithm of base c to both sides of this exponential equation. So we get that the log base c of x, okay, if we take the log base c of the left-hand side, is going to be equivalent to the log base c of b raised to the m, okay? And if you watch the previous Cram session on the power rule of logarithms, although technically the power rule of logarithms is probably a misnomer, but you still get the concept, you would recall that the logarithm of something raised to an exponent is the value of this exponent times the logarithm of this power. Okay, so let me show you what I'm talking about. So the log base c of x basically is going to be equivalent to m, which is the value of the exponent, times the log base c of b, okay? Our base or our constant now holds the place of the power position in the logarithmic expression, okay? I know variables and concepts are kind of getting intertwined, but just bear with me. I think you'll get, I try to understand the overall concept rather than harping on the labels of things, okay? All right, so now what we can do is basically simplify this by solving for m. And we can do this by dividing both sides of the equation by the log base c of b. So m is equivalent to the log base c of x here divided by the log base c of b. Okay, and what we now have is the right-hand side of our starting concept, which is going to be equivalent to m. But also remember that in the beginning, m was the value we assigned to the log base of b, therefore we can go ahead and undo our labeling, and we get that the log base c of x divided by the log base c of b is equivalent to the log base b of x, which is our starting formula or the change of base formula. Okay, so here is our proof, and we did it. Okay, so I just want you to take that all in for a moment, maybe catch up with yourself mentally. And while you're doing that, you might also be wondering, what's the point of all this? Well, knowing how to interconvert of these logarithmic formulas is relevant because they can be used to simplify and manipulate larger equations that you may be trying to solve in some type of algebra course, okay? So commit this formula to memory, and overall intellectual comprehension of this concept was not difficult. After the short amount of time it takes to complete